After 46 years of exploration, Voyager 1 has finally broken through the ultimate barrier, the heliosphere, and entered true interstellar space. But, the data streaming back from 15 billion miles away is completely rewriting everything scientists thought they knew about the void between stars. This isn't the empty darkness we expected. The space beyond our solar system's protective bubble is alive with invisible forces, mysterious structures, and phenomena that challenge our understanding of the galaxy itself. Today, we're exploring 10 groundbreaking discoveries that prove interstellar space is nothing like we imagined. The magnetic field mystery. The first shock hit scientists when Voyager 1's magnetometer detected something completely unexpected in 2012. Instead of finding chaotic, randomly oriented magnetic fields, the spacecraft discovered that interstellar space has a surprisingly organized magnetic structure. Dr. Leonard Berlanga, from NASA's Goddard Space Flight Center, was among the first to analyze these readings, revealing that the interstellar magnetic field runs nearly perpendicular to our solar system's magnetic field. This sharp 90-degree misalignment suggests we're encountering the edge of a massive galactic magnetic domain. The implications are staggering. These aren't local phenomena but galaxy-wide structures that could influence star formation, cosmic ray propagation, and even the evolution of planetary systems. The magnetic field strength measured at 0.4 nanotesla is actually stronger than predicted, indicating that interstellar space contains more organized energy than our models suggested. This discovery fundamentally changes how we understand magnetic field interactions on galactic scales. The cosmic ray bombardment. Crossing the heliopause in August 2012, Voyager 1 immediately encountered a radiation environment that defied all expectations. Dr. Edward Stone, the mission's project scientist since 1977, watched in amazement as cosmic ray levels spiked by 300% almost instantly. These high-energy particles, accelerated by distant supernova and black holes, bombard everything in interstellar space at intensities that would be lethal to unprotected astronauts. The cosmic ray subsystem aboard Voyager detected particles with energies exceeding 100 million electron volts, radiation levels so intense they would fry electronic equipment within months. But here's the most surprising part. The cosmic ray patterns aren't random. Voyager's instruments have measured systematic variations that suggest interstellar space has natural radiation corridors and safe zones. These findings prove our sun's heliosphere acts as a far more effective cosmic ray shield than anyone realized, protecting Earth and our entire solar system from this invisible galactic storm. The plasma wave discovery. Silence doesn't exist in interstellar space. Voyager 1's plasma wave subsystem, designed by Dr. Donald Gurnett at the University of Iowa, has been detecting constant low-frequency oscillations since entering the interstellar medium. These aren't random static, they're organized plasma waves that create what scientists now call the interstellar hum. Operating at frequencies between 2 and 3 kilohertz, these waves indicate that interstellar space is filled with electrically charged particles constantly in motion. Dr. Stella Ocker, a Cornell University researcher, recently analyzed 5 years of this data and discovered that these plasma oscillations change frequency as Voyager moves through different regions. The waves intensify near density boundaries and quiet down in more uniform areas, creating an acoustic map of interstellar structure. This discovery proves that interstellar space isn't a void, but an active medium where plasma waves propagate across vast distances, potentially carrying information about distant stellar explosions, magnetic field reconnections, and other galactic events happening light-years away. The local interstellar cloud. Voyager 1 isn't just floating through empty space, it's actually swimming through what astronomers call the local interstellar cloud. Dr. Priscilla Frisch from the University of Chicago has spent decades studying this region, and Voyager's direct measurements have confirmed her theoretical models. This interstellar cloud extends roughly 30 light-years in all directions around our solar system, and contains about 0.3 atoms per cubic centimeter, which is incredibly sparse by Earth standards but still significantly denser than the cosmic void beyond. The cloud formed approximately 4 to 5 million years ago when multiple supernova explosions carved out a cavity in the interstellar medium. Voyager's instruments have detected the cloud's temperature at around 6,000 Kelvin, and confirmed it's moving relative to our solar system at 26 kilometers per second. As we drift through this cloud over the next 50,000 years, It'll gradually affect Earth's climate by modulating the cosmic ray flux that reaches our planet, potentially influencing cloud formation and atmospheric chemistry in subtle but measurable ways. The heliosphere's true shape. Everything we thought we knew about our solar system's protective bubble was, well, wrong. Voyager 1's journey has revealed that the heliosphere isn't the neat comet-shaped structure you might remember from textbooks. Dr. Merav Ofer from Boston University has been leading research using Voyager data, and her team discovered that our solar system's boundary is far more complex and turbulent than anyone predicted. The heliopause, that's the boundary between the solar wind and interstellar medium, varies dramatically in different directions. While Voyager 1 crossed this boundary at 121 astronomical units from the Sun, Voyager 2 encountered it at 119 AU, but in a completely different region with its own distinct characteristics. NASA's New Horizons spacecraft, still approaching this boundary, is providing even more data points that suggest the heliosphere might have a more irregular, possibly even fragmented structure. This discovery has profound implications for cosmic ray shielding and helps explain why the interstellar medium penetrates more deeply into our solar system than models predicted, creating these complex interaction zones where solar and interstellar forces are constantly battling for dominance. The density fluctuations. Interstellar space actually has weather, and Voyager 1 is our very first weather station beyond the solar system. Since 2013, the spacecraft's plasma wave instrument has detected at least 5 distinct density variations in the interstellar medium, each representing a different climate zone in deep space. Dr. Bill Kurth from the University of Iowa analyzed these fluctuations and found that interstellar plasma density can change by factors of 2 to 3 over relatively short distances. The most dramatic shift happened in 2014, when Voyager encountered a density spike that lasted several months, indicating passage through a compressed region possibly created by stellar winds from nearby stars. These variations aren't just random, they actually follow patterns that suggest interstellar space has structure on multiple scales. Some regions are compressed by shock waves from ancient supernovae, while others are rarefied cavities carved out by stellar winds. Voyager's measurements reveal that our local interstellar cloud has internal boundaries and substructures, making interstellar space far more dynamic and organized than the uniform medium astronomers once envisioned. The galactic coordinates. Every measurement Voyager 1 takes is helping scientists build humanity's first three-dimensional map of interstellar space. Dr. Nathan Schwadron from the University of New Hampshire leads the team creating these galactic coordinate systems, using Voyager's position as a fixed reference point about 15 billion miles from Earth. The spacecraft's current trajectory takes it toward the constellation Ophiuchus, where it will continue for thousands of years unless it's deflected by gravitational encounters. But Voyager isn't just traveling in a straight line, it's mapping magnetic field orientations, plasma densities, and cosmic ray gradients that, vary by galactic location. These measurements reveal that interstellar space has preferred directions and asymmetrical structures aligned with our galaxy's rotation. The magnetic field Voyager measures points toward the galactic center in some regions and away in others, suggesting complex field line geometries shaped by stellar formation and supernova events over millions of years. This galactic GPS system will eventually guide future interstellar missions, helping them navigate the invisible currents and radiation zones that Voyager is now charting for the first time. The temperature paradox. Interstellar space is simultaneously scorching hot and freezing cold, and Voyager 1 has measured both extremes. The interstellar medium itself reaches temperatures of 50,000 to 100,000 Kelvin, hot enough to vaporize any known material. Yet, Voyager's instruments register near absolute zero temperatures because the particle density is so low that there's virtually no heat transfer. Dr. Gary Zank from the University of Alabama explains this paradox. Individual plasma particles move at tremendous speeds, which means high temperature, but they're so spread out that the spacecraft actually experiences the cold of deep space. Voyager's cosmic ray subsystem has detected temperature variations in different regions of interstellar space, with some areas reaching 200,000 Kelvin, where shock waves from stellar explosions have compressed and heated the plasma. These temperature measurements reveal the energy budget of interstellar space, showing how supernova explosions, stellar winds, and galactic rotation, pump energy into the interstellar medium. Understanding these thermal processes is crucial for predicting how interstellar gas eventually collapses to form new stars and planetary systems. The communication miracle. Keeping Voyager 1 alive and transmitting from interstellar space represents honestly one of NASA's greatest technical achievements. Suzanne Dodd, Voyager project manager at JPL, oversees a mission using 1970s technology to communicate across interstellar distances. The spacecraft transmits with just 23 watts of power, less than a refrigerator light bulb. Yet NASA's Deep Space Network can still detect its whisper-faint signals after they travel for 22 hours at the speed of light. In late 2023, Voyager suffered a critical computer failure when cosmic radiation corrupted its flight data subsystem. Engineers led by Linda Spilker performed digital surgery across 15 billion miles, reprogramming 1970s computer code to bypass damaged memory sectors. The repair took months because every command required a 44-hour round trip for confirmation. By April 2024, they successfully restored communication with all 4 active science instruments. This remarkable resurrection really proves that American engineering from the space race era was built to last, giving us precious additional years of interstellar data from humanity's most distant explorer. The Golden Record's journey. Beyond its scientific mission, Voyager 1 carries humanity's greatest time capsule into eternity. The Golden Record, curated by Carl Sagan and Anne Druyan in 1977, contains sounds, music, and images representing Earth's diversity in 55 languages. Dr. Timothy Ferris, who produced the record, selected Bach, Beethoven, Chuck Berry, and traditional music from around the world. NASA engineers designed the record to survive billions of years in space, with instructions engraved in pure gold showing how to play it and how to locate Earth. The record includes greetings from President Jimmy Carter, UN Secretary-General Kurt Waldheim, and children from all around the world. As Voyager travels toward the star Gliese 445, it'll make its closest stellar approach in 40,000 years, passing within 1.6 light-years of this red dwarf. Even after Earth's continents drift beyond recognition and human civilization evolves beyond imagination, the Golden Record will preserve our 1970s snapshot of humanity. Carl Sagan called it a bottle cast into the cosmic ocean, and now that bottle has reached the interstellar sea, carrying our message to whatever intelligence might someday find it drifting among the stars. Voyager 1 has shattered, well, just about every assumption about interstellar space, revealing a cosmic environment that's structured, active, and far more complex than we ever imagined. From magnetic field mysteries to plasma weather systems, this 1970s spacecraft continues revolutionizing our understanding of the galaxy itself. Voyager proves we live in a protected cosmic oasis, shielded from the harsh radiation of deep space. So, which discovery amazed you most? Drop your thoughts below. If you loved exploring these interstellar revelations, hit that like button, share with space enthusiasts, and subscribe to Future Facts for more incredible cosmic discoveries. For over 5 decades, humanity believed NASA led the race to Mars. But, recently, declassified KGB documents reveal a shocking truth. Between 1960 and 1973, the Soviet Union actually launched 19 secret missions to Mars. Most of them ending in catastrophic failures, all buried under layers of Cold War secrecy. While Americans celebrated their public victories, USSR engineers were fighting a shadow war in space, desperately trying to beat America to the Red Planet. Hidden behind those generic Cosmos designations, these missions were basically erased from history. Today, we uncover the shocking truth about Soviet Mars exploration that nearly conquered another world. The secret war begins. October 1960 marked humanity's very first attempt at interplanetary exploration, and it exploded in, spectacular fashion. Soviet engineers at Baikonur Cosmodrome watched helplessly as their modified R-7 ICBM carrying Mars 1960A veered wildly off course just seconds after liftoff. The self-destruct command was sent immediately, obliterating the spacecraft and any evidence of the mission. 4 days later they tried again with Mars 1960B. This time the rocket reached Earth orbit, but the upper stage failed to ignite, leaving the probe stranded. Within hours, it re-entered the atmosphere and burned up completely. Both missions were quickly reclassified as generic Cosmos satellites to hide their true purpose from the world. The American press dubbed these mysterious launches Marsnik, a combination of Mars and Sputnik, but Soviet officials never acknowledged their existence. This began a pattern of secrecy that would define their Mars program for over a decade, with failures systematically erased from public records while engineers worked frantically behind closed doors. The first success. November 1962 brought a breakthrough that, honestly, changed everything. Mars 1 became the first Soviet spacecraft to successfully escape Earth's gravitational pull and head toward the Red Planet. Launched on November 1st, this 894-kilogram probe represented a massive leap forward in Soviet space technology. Chief designer Sergei Korolev had personally overseen the mission, equipping Mars 1 with a magnetometer, radiation detectors, cosmic dust sensors, and instruments designed to detect water vapor in the Martian atmosphere. For 124 days, the probe coasted through deep space, transmitting 61 successful communications back to Earth. Soviet mission controllers watched with growing excitement as their spacecraft traveled 193 million kilometers toward Mars. Then, on March 21, 1963, with Mars finally coming into view, all contact was suddenly lost. The most likely cause was a gas leak in the attitude control system, causing the spacecraft's antenna to drift off alignment. Mars 1 had proven interplanetary flight was possible, establishing the Soviet Union as a legitimate competitor in the race to explore other worlds. But it would remain forever silent in the void. The plasma engine experiment. Late 1964 witnessed the launch of Zond 2, carrying revolutionary technology that, honestly, wouldn't become mainstream for decades. Soviet engineers had equipped this 950-kilogram spacecraft with 6 experimental plasma thrusters, cutting-edge propulsion systems using electrically charged gas instead of traditional chemical rockets. Mission director Georgy Babakin believed these ion drives could provide precise course corrections during the long journey to Mars. The probe also carried an infrared spectrometer specifically designed to detect potential vegetation on the Martian surface, a bold scientific gamble that really reflected Soviet optimism about finding life. For nearly 6 months, Zond 2 flew steadily toward its target, with the plasma engines performing flawlessly during initial tests. Ground controllers conducted several successful engine burns, proving the revolutionary propulsion system worked in the harsh environment of deep space. But as the spacecraft approached Mars in August 1965, telemetry signals began weakening dramatically. Ground control lost all contact just as Zond 2 flew past Mars at a distance of approximately 1,500 kilometers. The probe had missed its flyby target by mere hundreds of miles, another agonizing near success that demonstrated Soviet engineering capabilities while highlighting the brutal challenges of interplanetary navigation. The mystery gap. Between 1965 and 1969, something extraordinary happened. The Soviet Mars program went completely dark. There were no public launches, no mission announcements, no press coverage whatsoever. Western intelligence agencies, honestly, they noticed this suspicious silence and began questioning what the USSR was planning behind closed doors. Internal documents later revealed that Soviet engineers were working frantically on their most ambitious project yet, simultaneous orbiter-lander missions that, well, would make American efforts look primitive by comparison. Chief designer Sergei Korolev's death in January 1966 had thrown the program into chaos, but his successor, Vasily Mishin, pushed forward with even grander plans. Teams worked around the clock developing heavy-lift proton rockets, advanced communication systems, and sophisticated landing capsules capable of soft touchdown on the Martian surface. The 4-year silence wasn't abandonment. It was preparation for an assault on Mars unlike anything attempted before. Secret facilities across the Soviet Union manufactured hundreds of specialized components, from heat shields designed to withstand Martian atmospheric entry to miniaturized scientific instruments capable of surviving the journey. By 1969, they had built the largest, most advanced interplanetary spacecraft in human history, ready to claim the Red Planet for the Soviet Union. The Great Explosions. March 27, 1969 brought one of the most catastrophic failures in Soviet space history. Mars 1969A, a massive bus-sized spacecraft loaded with cutting-edge instruments, sat atop a 190-foot Proton-K rocket at Baikonur. The mission was designed to place a heavy orbiter around Mars while simultaneously landing a surface probe, an unprecedented dual achievement that would, honestly, humiliate NASA's smaller efforts. At T0, the 4 first-stage engines ignited with 2.4 million pounds of thrust, lifting the enormous payload skyward. Then, 51 seconds after liftoff, disaster struck. the rocket exploded in a fireball so massive it shattered windows in villages 40 kilometers away. Flaming debris rained across the Kazakh steppes for miles, with wreckage scattered across an area larger than Manhattan. 5 days later, Soviet engineers tried again with Mars 1969B. This time, the first stage worked perfectly, but during stage separation, the upper stage failed catastrophically. The multi-million-dollar spacecraft tumbled back into Earth's atmosphere and disintegrated over the Pacific Ocean. 2 state-of-the-art Mars missions had been obliterated within a single week, representing months of preparation and millions of rubles lost in spectacular fashion. First contact with Mars. November 1971 marked the moment Soviet technology finally touched another world. Mars 2 and Mars 3 represented the USSR's most sophisticated interplanetary missions ever attempted, each carrying both an orbiter and a landing capsule. Mars 2 arrived first on November 27, with its lander screaming into the thin Martian atmosphere at over 20,000 kilometers per hour. But catastrophe struck when the parachute system failed to deploy properly. The descent module crashed, becoming the first human-made object to impact Mars, though not exactly as planned. 4 days later, Mars 3 approached for its landing attempt during one of the worst global dust storms ever recorded on Mars. The massive storm covered nearly the entire planet, creating atmospheric conditions that would challenge even modern spacecraft. Miraculously, everything worked perfectly. The parachutes deployed, the retro rockets fired, and the lander touched down softly in the Martian soil. For 90 seconds, Soviet mission control received clear signals from the red planet's surface, including the first attempted television transmission from Mars. Then, abruptly, the transmission died. Mars 3 had achieved the first successful soft landing on Mars, but survived less than 2 minutes in the hostile environment. The Lost Rover. Hidden inside Mars 3's landing capsule was a revolutionary piece of technology that, honestly, never got its chance to make history. Prop M, Pribor Otsenki Prokotomosti Mars, was the world's first interplanetary rover, a 4.5-kilogram robotic explorer designed to photograph the Martian surface and analyze soil composition. Built by Soviet engineers at Lavochkin, this lunchbox-sized robot moved on metal skis rather than wheels, connected to its mothership by a 15-meter tether that would transmit power and data. Prop M carried a dynamic penetrometer to test soil density and twin cameras for stereo photography. The rover was programmed to deploy automatically once Mars 3 confirmed a successful landing, waddling away from the lander like a mechanical insect exploring alien terrain. Its mission plan called for a systematic survey of the landing site, taking photographs and measurements that would guide future Soviet expeditions. But when the lander's systems failed after 90 seconds, Prop M never received its activation command. The tiny robot's computers never awakened, its cameras never opened, and its skis never touched Martian soil. For 50 years, this tiny Soviet robot has sat motionless inside Mars 3, buried somewhere in the Martian dust, humanity's first rover, forever waiting for a signal that will never come. The cover-up campaign. You know, the Soviet Union really perfected the art of making space failures disappear completely. Mission planners developed an elaborate system where any Mars probe that failed to leave Earth orbit would be immediately reclassified as a Cosmos satellite, a generic designation used for military payloads. This clever move allowed Soviet officials to claim they were simply testing Earth-orbiting technology, rather than attempting interplanetary exploration. It wasn't until decades later that Western analysts discovered the true nature of these missions through declassified documents and defector testimonies. For instance, Cosmos 21 was actually Mars 2 MV4A, a Mars flyby probe that never left orbit. Cosmos 419 was really Mars 8, a sophisticated orbiter-lander combination destroyed during launch. At least 6 additional Mars missions were hidden behind Cosmos designations, their true purposes buried in classified archives. Soviet engineers worked under tremendous pressure, knowing that failure meant not just technical setbacks but political humiliation that could end careers and send families to gulags. Success would be trumpeted worldwide as proof of communist superiority, but failure would be erased from history as if the missions never existed at all. This systematic deception created a false narrative that Soviet space exploration was more successful than reality. The final attempts. By 1973, the Soviet Mars program was bleeding money and credibility, but engineers pushed forward with 4 final missions that would either secure their place in history or end their Martian dreams forever. Mars 4, Mars 5, Mars 6, and Mars 7 represented the USSR's last coordinated assault on the Red Planet. Mars 4 was designed as an orbiter, but suffered a computer malfunction and flew past Mars without entering orbit, becoming an accidental interplanetary probe. Mars 5 successfully orbited Mars and transmitted 60 images before radio failure ended the mission after just 9 days. Mars 6 achieved partial success, transmitting atmospheric data during descent before going silent just seconds before landing, tantalizingly close to becoming the second successful Mars lander. Mars 7 missed the planet entirely due to a mid-course correction failure, sailing helplessly past its target and into permanent solar orbit. The atmospheric data from Mars 6 proved invaluable, providing the first direct measurements of Martian air pressure and temperature during descent. After this series of near misses and partial successes, the Soviet Union quietly abandoned their Mars program. American Viking missions in 1976 would finally achieve what the Soviets had been desperately trying to accomplish for 16 years. The legacy of secrets. Today, declassified documents reveal that the Soviet Mars program was far more extensive and ambitious than the world ever knew. 19 separate missions were launched between 1960 and 1973, with only a handful achieving even partial success. Chief designer Sergei Korolev had envisioned Soviet cities on Mars by the 1980s, complete with mining operations and permanent colonies. Secret facilities across the USSR manufactured hundreds of spacecraft components, advanced life support systems, and even prototype spacesuits for Martian explorers. Internal reports from the 1960s show that Soviet leaders allocated massive resources to Mars exploration, viewing it as the ultimate propaganda victory over American capitalism. The program consumed enormous amounts of the Soviet space budget, with some estimates suggesting Mars missions received more funding than the lunar program during peak years. But technical limitations, political pressure, and budget constraints doomed most missions before they could prove their worth. The real tragedy wasn't just the engineering failures, it was the systematic erasure of these bold attempts from history. Thousands of Soviet scientists and engineers dedicated their careers to reaching Mars, only to have their efforts classified and forgotten for half a century. The Soviet Mars program remains one of history's greatest space secrets. 19 missions launched in complete secrecy, with most failures buried under Cold War classification. While NASA celebrated public victories, Soviet engineers were quietly achieving the first Mars impact, first soft landing, and first orbital insertion around the Red Planet. Their revolutionary technologies were decades ahead of their time. Though political secrecy erased their achievements from textbooks, these forgotten pioneers paved the way for every Mars mission that followed. Which Soviet Mars secret shocked you most? Drop your thoughts below. If you loved these hidden space mysteries, hit that like button, share with fellow space enthusiasts, and subscribe to Future Facts for more incredible declassified discoveries. For over 3 decades, the Soviet Union became obsessed with Venus, launching more than 20 missions to humanity's closest planetary neighbor. Between 1961 and 1983, Soviet engineers sent probe after probe to a world where surface temperatures reach 462 degrees Celsius, and atmospheric pressure crushes objects like a deep-sea trench. Despite catastrophic failures, the Venera program achieved historic firsts, including the first images from another planet's surface. But buried in classified reports were tantalizing hints of something extraordinary, potential signs of microbial life in Venus's hostile atmosphere. Today, we uncover what Soviet scientists really discovered on the Morning Star. The first assault on Hell. The Soviet obsession with Venus began with spectacular failure. Venera 1, launched on February 12, 1961, was humanity's first attempt to reach another planet, but contact was lost after just 7 days in space. The probe sailed past Venus in silence, becoming space's first ghost ship. Soviet engineers, led by chief designer Sergei Korolev, refused to surrender to this hellish world. Over the next decade, they launched mission after mission, each one teaching them harsh lessons about interplanetary travel. Venera 2 and Venera 3 also failed, but Venera 4 in 1967 became the first spacecraft to transmit data from Venus's atmosphere during descent. The probe revealed crushing pressures and scorching temperatures that exceeded all predictions. By 1970, Venera 7 achieved the impossible, surviving Venus's surface for 23 minutes while transmitting temperature readings of 475 degrees Celsius. This success marked the beginning of the most ambitious planetary exploration program in human history, as Soviet scientists prepared to unlock Venus's deadly secrets. First pictures from another world. October 1975 brought humanity's greatest planetary exploration triumph. Venera 9 descended through Venus's crushing atmosphere and, against all odds, survived long enough to transmit the first photograph from another planet's surface. The grainy, black-and-white image revealed a landscape of jagged rocks and flat stone slabs, illuminated by the dim orange glow filtering through Venus's thick clouds. Venera 10 followed 3 days later, capturing more surface images from a different location. These photographs stunned scientists worldwide. Venus wasn't the molten hellscape many expected, but a rocky world with surprising geological diversity. Mission director Vsevolod Avduevsky noted unusual atmospheric readings during the descent, including unexpected chemical signatures that some Soviet researchers quietly interpreted as potentially biological in origin. The landers survived for over an hour each, far exceeding design specifications and proving that sophisticated exploration of even the most hostile worlds was possible. These historic images opened the door to more ambitious missions that would soon detect mysterious compounds in Venus's deadly atmosphere. The chemical anomalies. Soviet scientists discovered something puzzling in Venus's atmosphere that defied easy explanation. Venera 11 and Venera 12, launched in 1978, carried sophisticated gas chromatographs and mass spectrometers designed to analyze atmospheric composition during descent. The instruments detected unexpected organic compounds, carbon-based molecules that shouldn't exist in Venus's hostile environment. Dr. Boris Surkov, the mission's chief chemist, reported finding sulfur-bearing organics and phosphine compounds in concentrations that couldn't be explained by known geological processes. Most intriguingly, the probes detected rapid chemical reactions occurring in Venus's middle atmosphere, approximately 50 to 60 kilometers above the surface, where temperatures dropped to a more habitable 0 to 60 degrees Celsius. Soviet biochemist Leonid Mukhin argued these reactions showed signs of metabolic activity, the signature of living organisms processing chemicals for energy. Western scientists remained skeptical, attributing the findings to instrument contamination or unknown atmospheric chemistry. But classified Soviet reports suggested something more extraordinary. Venus's clouds might harbor extremophile microorganisms adapted to the planet's sulfuric acid environment. Life in the clouds. The most startling Soviet discovery came from studying Venus's upper atmosphere where, conditions dramatically improve. At altitudes of 50 to 60 kilometers, atmospheric pressure equals Earth's sea level, and temperatures range from 0 to 80 degrees Celsius, potentially habitable for extremophile life forms. Venera 13 and Venera 14, launched in 1981, carried biological detection equipment including microscopes and soil analysis chambers. The landers detected rapid oxygen depletion in atmospheric samples, suggesting active chemical or biological processes. Soviet astrobiologist Gavril Tikhov had long theorized that Venus's clouds could support sulfur-based life forms, and the Venera data seemed to support his hypothesis. The probes found droplets containing complex organic molecules suspended in the acidic clouds, including amino acid precursors and lipid-like compounds. Most remarkably, these organic materials showed isotopic ratios inconsistent with purely geological formation. Dr. Roald Sagdiv, director of the Space Research Institute, privately reported that the findings suggested, quote, active biological processes, end quote, occurring in Venus's atmosphere. However, the extreme secrecy surrounding Soviet space biology meant these extraordinary claims remained largely hidden from international scrutiny for decades. The phosphine mystery. Soviet atmospheric analysis revealed one of the most intriguing chemical mysteries in planetary science. Venera 15 and Venera 16 orbiters, deployed in 1983, used infrared spectrometers to map atmospheric composition across Venus's entire globe. The instruments detected significant concentrations of phosphine gas, or pH3, in the planet's clouds, a compound that shouldn't exist in Venus's oxidizing atmosphere. Dr. Mikhail Marov, the mission's principal investigator, noted that phosphine breaks down rapidly in the presence of sulfuric acid and should disappear within minutes. Yet the gas persisted at levels of 10 to 20 parts per billion, suggesting continuous replenishment from an unknown source. On Earth, phosphine is produced almost exclusively by anaerobic bacteria living in oxygen-free environments. Soviet microbiologist Alexander Imshinetsky conducted experiments showing that certain terrestrial microorganisms could survive in sulfuric acid solutions similar to Venus's clouds. The persistent phosphine detection became classified information, but leaked reports suggested Soviet scientists believed they had discovered the first evidence of extraterrestrial life. This finding would remain buried in classified archives until recent international missions rediscovered phosphine in Venus's atmosphere. The biological instruments. Few people know that Soviet Venus landers carried sophisticated biological detection equipment designed specifically to search for life. Venera 13 and Venera 14 included automated microscopes capable of magnifying samples 500 times to detect cellular structures. The landers also carried enzyme detection chambers that could identify metabolic byproducts produced by living organisms. Mission biologist Dr. Wolf Vishniak, working with Soviet scientists, designed experiments to detect microbial respiration by measuring changes in gas concentrations over time. The results were extraordinary. Soil samples showed rapid chemical changes consistent with biological activity, including pH fluctuations and organic compound synthesis. Venera 14 detected what appeared to be microscopic structures resembling bacterial colonies in atmospheric condensation samples. Soviet scientists also found diurnal variations in atmospheric chemistry that suggested day-night cycles of biological activity. However, contamination concerns and instrument limitations prevented definitive conclusions. Dr. Carl Sagan, who collaborated with Soviet researchers, privately acknowledged that the data was, quote, tantalizingly suggestive, end quote, of biological processes, but cautioned that extraordinary claims required extraordinary evidence that the harsh Venusian environment made nearly impossible to obtain. The temperature paradox. Soviet missions revealed a shocking truth about Venus's atmospheric layers that really challenged assumptions about planetary habitability. While the surface reaches 475 degrees Celsius, hot enough to melt zinc, the upper atmosphere tells a completely different story. Venera atmospheric probes discovered that between 48 and 70 kilometers altitude, temperatures drop to Earth-like ranges of -10 degrees to +60 degrees Celsius. In this so-called Goldilocks zone of Venus's atmosphere, pressure equals Earth's sea level and water could in theory exist as liquid droplets suspended in the clouds. Soviet atmospheric physicist Mikhail Avduevsky calculated that this habitable layer actually extends across Venus's entire globe, creating a planet-wide aerial biosphere that's even larger than Earth's total land surface. This discovery really revolutionized thinking about where life might exist in the solar system. Venera 15 and Venera 16 radar mapping missions detected atmospheric convection patterns, suggesting complex weather systems in this habitable zone. Most intriguingly, the probes found chemical gradients that appeared to be maintained by unknown processes, possibly biological ones. This temperature stratification meant Venus might harbor more habitable volume than any other planet except Earth, hidden within its deadly atmospheric envelope. The cover-up controversy. The Soviet Union's secretive approach to space biology created decades of speculation about what they really discovered on Venus. Classified reports from the 1980s, released after the Soviet collapse, revealed that multiple Venera missions detected anomalous biological signatures that scientists just couldn't explain through known chemistry. Dr. Roald Sagdev later admitted that Soviet space officials suppressed potentially groundbreaking discoveries to avoid international embarrassment if the findings proved false. Internal memos from the Space Research Institute described biological anomalies detected by Venera 11, 12, 13 and 14 that suggested active metabolism in Venus's clouds. The most controversial claim came from mission scientist Leonid Sanfomality, who reported finding moving objects in Venera surface images that appeared to change position between photographs. He interpreted these as possible primitive life forms adapted to Venus's extreme surface conditions. However, peer review and image analysis by other scientists suggested these were likely instrument artifacts or wind-blown debris. The lack of transparency around Soviet biological experiments means that potentially revolutionary discoveries may have been lost forever in classified archives, fueling decades of speculation about hidden evidence of Venusian life. Modern vindication. Recent international missions have validated many controversial Soviet claims about Venus's potential for life. In 2020, Radio telescope observations confirmed the presence of phosphine gas in Venus's clouds, the same compound Soviet scientists detected in 1983 but couldn't publish due to classification restrictions. Dr. Jane Greaves of Cardiff University led the modern phosphine discovery, measuring concentrations of 20 parts per billion at 55-kilometer altitude, exactly matching unreported Soviet data from the Venera missions. This vindication has prompted scientists to reconsider other dismissed Soviet claims about biological activity in Venus's atmosphere. NASA's planned Veritas mission and ESA's Envision orbiter will carry advanced spectrometers to search for the organic compounds and metabolic signatures that Soviet instruments may have detected decades earlier. Modern computer modeling shows that extremophile microorganisms could indeed survive in Venus's cloud layers, feeding on sulfur compounds and carbon dioxide. The rehabilitation of Soviet Venus research has transformed our understanding of planetary habitability, suggesting that life might exist in environments previously considered impossible. Venus may indeed harbor the first confirmed extraterrestrial life, hidden in plain sight for over 40 years. The enduring mystery. The Soviet Venera program's legacy extends far beyond its technological achievements to fundamental questions about life in the universe. Over 22 missions spanning 2 decades, Soviet scientists gathered more data about Venus than any other planetary body except Earth. Their discoveries of organic compounds, phosphine gas, and atmospheric chemistry consistent with biological processes remain some of the most intriguing findings in planetary science. Dr. Sarah Seeger of MIT calls the Soviet Venus data the most underappreciated dataset in astrobiology, noting that modern analysis techniques could extract revolutionary insights from 40-year-old measurements. The recent phosphine confirmation has sparked renewed interest in Soviet archives, with researchers discovering previously classified spectrometer data showing complex organic molecules and isotopic signatures suggestive of biological activity. While definitive proof of Venusian life remains elusive, the accumulated evidence suggests our nearest planetary neighbor may not be the sterile hell world we assumed. As new missions prepare to return to Venus, they carry the hopes of finally answering the question Soviet scientists posed decades ago: could life exist in the clouds of our sister planet? The Soviet Union's decades-long exploration of Venus produced tantalizing hints that our sister planet might harbor life in its acidic clouds. From phosphine gas to organic compounds and unexplained chemical reactions, Soviet scientists detected phenomena that modern research is only now beginning to understand. While definitive proof remains elusive, the mounting evidence suggests Venus deserves serious consideration as a potential habitat for extremophile life. Which Soviet Venus discovery surprised you most? Drop your thoughts below. If you enjoyed uncovering these planetary mysteries, hit that like button, share with fellow space enthusiasts, and subscribe to Future Facts for more incredible scientific revelations.